Welcome to Rubber Duck Engineering. In this episode, we're going to keep working on our render tree. We're going to add hit testing, event propagation, and Eric wants to do a line box tree, which I think is a little bit ambitious.
There's no way.
Hi, Eric. Welcome back.
Oh, thank you. Hello, Dr. Barth. It's like my body thinks it's like 3 a.m, so we're doing this on fumes.
But delicious, delicious fumes.
Delicious fumes. It's wonderful to be back. I'll tell you, I don't know. I've been off on vacation for a couple weeks now, I'm back now, but it's wonderful, wonderful.
Coming home nice? You back to familiar surroundings?
Well, other than the fact that the sky's on fire here, otherwise, when we were coming in on a plane and like it was boom, they're like, yeah, sorry, there's wildfires, makes it hard to fly.
Oh, really? It makes like an atmospheric disturbance even for the airplane.
I don't know whether they just were bad at flying an airplane.
It was a convenient excuse, and I believe it.
But it was a very rough last hour or something in the plane, and then I came home to orange skies. But otherwise I'm in beautiful California. So, but yeah, I heard you build a line box tree, or not a line box tree. You built a render tree.
Yes. Yeah, last episode we put together sort of a minimal bare bones render tree, and we have layout, and we have a couple dirty bits, and then we have a paint phase.
Okay.
And I think if you look at the code carefully, you'll find that it's full of an enormous number of bugs. But that's the place to start.
Good.
I didn't tech up on unit testing, so it may be a little bit hard to actually squash the bugs. But
okay. I've been a little busy on vacation and all, and so I haven't actually watched last week's. But I'm sure.
Would you want a quick tour of what we did?
I would love a quick tour. Let me figure out how to hit the quick tour button here. Because I think I'm the code machine this week.
Yes, you are the code machine. So do you want to start in main.js?
Main.js. So
this is sort of like a harness kind of program. The render tree is in the other file. But this thing basically loads up this library called Canvas Kit, which I think you're familiar with. Is a WASM compilation of Skia. Yep. And then there's this draw frame loop, which is quite similar to the animation loop, both in web browsers and also in Flutter. This is our very basic on-click handler. It basically grabs in the middle of the tree and mutates the render tree. So I think what might be a fun thing to do in this episode is turn this into a proper hit test, where we take the coordinates of the click event and then use that to determine which render object is affected, and then direct the event at that render object.
Yeah, I think that'd be great. This code all makes total sense. As you said, yeah, I'm totally familiar with Canvas Kit.
I have the fancy thing. Let's see if I can project this. Healthy trees should be full of bugs. Oh, is that true? Is that how forestry works? I fail to grow plants. They always die when I try to take care of them.
My kid listens to a podcast, and they were explaining, I don't know, a couple months ago now, I guess it's been a while, about how trees fart. But anyways, that's what that reminded me of. They're probably also full of bugs. Things you learn when listening to podcasts with children, or children-oriented podcasts. All right, so this file I totally understand. This all makes sense.
If we look at lib.js, this is where I'm sort of putting the generalizable library code. So offset is just a class that represents a point in 2 dimensions, very similar to the offset class in Flutter. Size is size. I didn't make a rect class. We might end up making one. We'll see. Box constraints, also very similar to the box constraints in Flutter. So it's the thing we pass through layout to sort of give the child some idea of how big it should be. And then I added a few. Yep.
It's all very reminiscent of basically Flutter 1.0.
Yep.
Like before we moved to Dart and all that. But go ahead.
Yeah, so just added some basic functions for manipulating the box constraints. On in Flutter, we have a ton of these because that is very convenient. It follows the same paradigm where these objects are meant to be used immutably. So like each one of these, like trim height doesn't mutate the box constraints. It returns a new box constraint object. In Dart, you can declare things final and constant stuff.
We need a T, yeah.
Oh, go ahead, fix it.
Well, but then I'm going to break any callers of it.
Okay.
And we have no way to know because we don't have any unit tests.
We have
we don't have a compiler either.
Is what we have. Boom, now there's a T.
Oh, who knows what it'll do. Okay.
I totally broke this. Okay, fixed. Yeah, so then window is, this is the thing that we might want to elaborate as we do hit testing. This is the thing into which the render tree is put. So it would make a lot of sense to put the root of the render tree as a member on the window. It's not how it's set up right now, but that would make sense.
Okay. It's a little weird when thinking about targeting a web environment that you have to like somehow have a window, but okay.
Oh, I was trying to get sort of away from the idea of being web. I wanted to create sort of like a self-contained world to play with.
Okay.
Render box, this is the base class of the render tree. So if we were to do line box, we probably have to introduce a new base class that was...
Yeah. For those of you who don't know, line box trees, maybe, well, my limited experience with them, which I guess I've seen a few of them, they're typically used for laying out text. And they're way more complicated, or they're a very complicated piece of the rendering tree.
I think the reason that's important to realize is when you lay out text, you might come to a word that then breaks over a line. And so like a run of text or a span of text isn't actually a rectangle on the screen. And so you need a different data structure to represent this kind of like wrapping thing. And so the concept of a box, like a render box, doesn't generalize to lines.
Yep.
And so what we do in Flutter and in other render trees is box is usually not the base class of your render tree. Usually you have a thing called like render object. So that's more abstract that can then handle things like line box trees as opposed to boxes.
Okay, so render box, and we have mark needs layout.
Yeah, so we currently only have one dirty bit. So the dirty bit is for whether yourself or your child needs layout. We don't have a painting dirty bit. We always just paint the whole tree. Yep. I think in Flutter we have a myself is dirty for layout, and one of my descendants is dirty for layout. We have two separate bits for that. This is simplified.
Okay.
So then this perform layout basically does the cutoff of the layout walk if the child doesn't need layout. So this check is actually somewhat incorrect. So maybe a thing we could do is we could make this more correct. So a big reason this isn't correct is if the parent passes different constraints because its layout changed, then with the code as written, if the child is clean, it will just ignore those constraints and they won't take effect. So what we probably should do is, and also what Flutter does, is cache the constraints from last time and check to make sure they're the same before cutting off the layout walk.
Yeah. Okay. And we haven't, this thing doesn't implement paint. It just makes it, is this even needed in JavaScript?
No, I just declared it there so I could have it to copy and paste.
Okay.
And then render single box child is just a base class for managing a single child.
What does JavaScript do if you don't do this?
It complains at runtime.
Oh.
We try to satiate.
Oh, okay, good. Sorry, all of my either JavaScript unfamiliarity or JavaScript prejudices are definitely going to come forth.
JavaScript is a language that it's so ubiquitous that everyone has an opinion about. So I don't think you should try to hide your prejudice or opinions. Like,
oh yeah. It's also, yeah, anyways. Okay.
You may realize that on the show, we do a tour of like every language known to humanity. And mysteriously, the one day when Eric wasn't here, we decided to do our JavaScript project.
Well, I have spent many decades of my life working on JavaScript, but mostly from the like making JavaScript work perspective rather than writing very much of it.
But I think I've written more JavaScript in tests than I've written JavaScript in production code.
Easily. The only time that I wrote JavaScript professionally was my startup, where we did Rails and we wrote, JavaScript front end stuff. And yeah, it is a useful hammer to have. But wow, I can't imagine writing on it all day, every day. Anyways.
Yeah, you need tools to support you. We don't have all the tools set up here.
We need
really
unit testing.
YOLOing our JavaScript universe.
Okay, so we have our render system block child, fine, which is sort of an optimization, but
yeah, just a way of sharing code.
Render root, which is a render system blocks child, yeah.
So this thing just knows how to embed inside a window and applies the device pixel ratio. So that scales. Yeah.
How is this different from window?
Because window is not a render object. This is a render object.
This feels like this goes inside the window.
That would be a fine thing to do. Sure.
Which is like, okay, go ahead.
It's possible. It's possible you want to basically move a lot of this. Like maybe it's sensible for the window to apply the scale transform before calling into the render tree. I think that would be a totally sensible organization.
Yeah, I suspect so. Anyways, I think that we probably need to get to unit, like, this isn't very much code, right? This is 250 lines of code, but it's enough code where, anyways, we could break it easily. But keep going.
Then render size box. This is just a box that has a preferred size, and in layout it tries to be as close to that size as possible.
And then up and down.
In X and Y, yep. And then it just has a color that it tries to paint. It fills itself.
Like constraints constrain. What does this do?
Constraints constrain takes in a size and tries to gives you back a size that both meets the constraint and is as close as possible to the size that you passed it.
I see. So it the being as close as possible is.
So like if you're too big if your width is too much, then it clamps you to the max width. Or if your width is too small, it raises you to the min width. This is the same way that Flutter works, which is each render object is required to respect its constraints. And so it tries to get as close as possible. So there's a widget in Flutter, for example, called sized box. It does a little bit more sophisticated, but roughly what this does.
Okay.
And then render top and bottom is supposed to be an example of sort of a non-trivial layout. It has a child that it puts on top, and then the next child it puts underneath it.
And I see. Here's your discussion that we don't have like a rect abstraction, because normally we wouldn't like claw into Skia directly here, or at least in Flutter we don't.
Yeah, we're like handwriting a lot of this arithmetic that if you have a nice, typed data structures, you can get them to do it for you more easily.
All right, render top and bottom. What does this do?
So this takes two children, the two named children, one called name top and one called bottom, and just positions the top one at 0, 0, and then positions the bottom one at 0, y, where y is the height of the top one.
And how does it distribute height between them?
So it basically asks the first one how big it wants to be, and then any remaining height it allows the child to occupy.
Okay. All right. Cool. All right. So, did you have in your mind? You talked about you want to do hit testing.
Yeah, I think we should totally do hit testing.
All right. That sounds like fun. And we've seen this run. Let me see if I still remember how to make it go. Oh no! Did I break it?
Try reloading it.
I think if I just do this, show in browser preview, this might work.
I think you showed the.
I showed the wrong thing. Show open in browser preview. No, I somehow broke it. Oh, there we go.
There you go. Yeah, so in this case, green is the top and yellow is the bottom.
If we look at main.js, we'll see that. Oops.
Yep. And so I think it might be neat is if when we clicked on one of these boxes, then we would use hit testing to find the sized box and then have it react by maybe changing its color or something.
Because right now when we click on this, it grabs your size box top and just makes it bigger. So presumably green, yep, just keeps getting taller.
Yeah, so if you go look at the top, when we build the render tree, we save out these references to the different children that we want to manipulate. But the way you would normally do this is you just have all the children buried in the render tree and then you use hit testing to go find the interesting
Makes
things.
sense. Okay. So, all right. So I think I would probably write the code that I want this to look like, and then I would make it real, following my pattern of
yeah, let's go for it.
Writing code. All right. So we'd want to do something like window.hitTest.
So I think this onClick handler will get an event in JavaScript that will tell us something interesting. We can do like we can do like a log or something to figure out exactly what it is, but I think it's going to be like X and Y. So I would make this an offset, right? Like that.
Okay. And then this should be object. And then this is actually, everything's a render box, right?
Yep.
And we just want to do
maybe box.handleEvent. Do click event.
Oh, why is that? So I guess in this world, we're not separating out like the DOM from the render tree like a browser does, or like widgets from the render tree. Like,
oh, so you just want to directly? We can just directly manipulate the size. We can do event propagation as a second phase. So like this.
Sure. Is that a valid thing on set preferred size? Like, will every box respond to that?
No, only the one box that knows about that. That's why I thought maybe handle event would be better, because we can make every render object understand handle event, and then we can handle the event specifically in size box to adjust its size.
Sure. It's a little weird that we're then like shoving a bunch of stuff into.
I agree, but like I think because this is a fairly simple example, it's okay to basically hard code some things, and then as we build it up, we can abstract it and
yeah, let's make this work. I guess we could do, what is it? What's JavaScript? It's like window.log.
Console.log.
Console.log. So it worked on browsers.
Yep.
And then this thing, wait, is there a console for this? I bet it's this console.
I think it's the debug console, or maybe the output console. I never know.
What is the .NET? No idea.
I just try clicking on things and see what happens.
Okay. That doesn't seem to work.
Okay. I had this set up before with debugging, but you want to try alert? See if alert works.
Alert.
Hold alert.
What?
Object pointer event. That worked.
We're doing it. We're doing alert debugging.
William has a comment. Is it worth calculating relative coordinates for the child? Yes. So we'll probably need to do that as part of our hit testing. We'll get to that.
Okay. Did we find that X works?
I need to reload. Yep.
All right. We got it. All right. So that should work.
Alan. Hello, Alan.
Hey, Alan. All right. So that should work. And so now we have to implement hit test.
Yep.
on window. Okay, hit test offset.
So we're immediately going to hit the problem that our window doesn't have our render tree associated with it.
All right, well, so let's hit test our root instead.
Okay.
Just for giggles, because we have to really this hit test has to be a render box method. Hit test recurse.
And so the way we did this in Flutter, which I think is somewhat sensible, is we had another function called hit test self.
Oh.
Which is the thing that children are supposed to override. But the idea is that hit test is the thing that walks the tree, and then it tries to hit test, and then hit test self checks whether you yourself have been hit. So the default implementation of hit test would be to return this. And that allows things like render box child.
Yep. To just change this one.
Correct.
Yeah, you're splitting out your idea of your child model from your hit testing model, from your drawing model. This makes a lot of sense.
So then you have to think about
I see you're down here. Okay.
So maybe hit test. So you say if I hit test myself, then return this. Otherwise, return this.child.hitTest.
That feels wrong. Wouldn't you want to hit don't your children paint in front of you?
That's a good point.
I guess this depends on your paint order.
Hit equals this. If it equals null, return it. Actually, then this can just call super.
Yeah.
So, we're doing a very simple hit test that just returns a single render object. There are fancier versions that will return a array of them or something
Sure.
But this seems fine for now.
Yep. Yep. All right. So we need to actually hit one of these that actually knows how to hit test self. It's one of these things do we have any of these that are painting?
Yeah. So render size box when hit test self should just return true, I think.
No, it doesn't have to. It's got to check against its local coordinates, doesn't it?
Well, so that now you have a good question of whose job is that. So I think, yeah. So why don't we make it the job of the child to do that? So we would say offset.dx is less than size.
Yeah, I think you should check against your own coordinates because you might paint in a non-boxy manner, right? Or might want to have a hole in yourself.
Do we check for positivity too, offset.dx is greater than or equal to 0?
Oh, because offset is in relative coordinates?
Yeah, so I think we should we have to make all these choices. I think a natural thing to do is to have offset be in relative coordinates.
Yeah, I agree.
So we'll have to do that for render top and bottom to do the coordinate adjustment.
You're bringing back memories of when I worked on refactoring WebKit to move to having objects for points and offsets and recs. Because WebKit for the longest time would just pass around the KHTML that we inherited. Just had everything split, and it was like int x and int y and int dx and int dy.
Yeah, so this is a really good example of where a rec class would make this code way easier to write and way more likely to be correct.
Yep. which I think we're going to very quickly graduate to. Honestly, we're very limited by our total lack of unit testing. We're limited by our choice of language combined with our lack of unit testing.
Yep, we're totally YOLOing this. I don't know how many episodes we'll be able to sustain this project before it collapses under its own weight.
Yeah, about 5 more minutes. Well, to point out just that we have chosen a duck typing language, like a dynamic language, which is great. Dynamic languages are wonderful, but then they require, for them to actually be sturdy, you to get to really high levels of unit test coverage.
And we're also running a very highly structured program. Like, we're using a lot of multiple levels of inheritance and overrides and all that stuff without any of the guardrails that will help us stay on those tracks.
Yep. Yeah, because it's very easy for us to have a typo in one of these overrides, and then we have no way to know that we're not hitting our override. Okay.
All right, should we try top and bottom?
Is this supposed to be less? Why are we inclusive on the 0, but exclusive on the...
This is another philosophical question. Why
is the top left included?
This is just traditional. So this is so that every pixel, suppose you had a bunch of boxes laid out next to each other. You want every pixel on the screen to hit exactly one box. So if you didn't include 0, then the 0, 0 pixel would miss. And if you did include width, then the whatever it is, the wth pixel would be overlapped between the two. And so this is actually a thing that started in Xerox, where they decided that the left end would be included and the right end wouldn't, and everyone else has just been carver culting it ever since.
Okay. You were saying, sorry, then. After...
I was going to render top and bottom.
Okay. Which is down here.
So equal top.
And which is in the top is over the top of the bottom? In this
the top is at 0, 0, and the top is the green one, and the bottom is the yellow one.
I'm pointing out that our hit testing order should align with our paint order.
Okay, so if you look in the paint function, you'll see what the paint order is.
And it looks like the bottom paints over the top of the top, even though they shouldn't actually ever overlap, which should mean that our bottom should hit test before our top does.
So we're gonna have to hit test bottom. Now we need to adjust our offset, right?
Yes, for this. Yeah, so the offset we assume is in our relative coordinates.
Right, so we have bottom's offset. So we need to somehow, I gotta figure which way the math goes. So if it's at y equals 10, and the offset is,
I think
you want to subtract.
We just want this offset minus bottom's offset.
Yeah, so this is JavaScript, so we can't overload operators as far as So we have to go like that, which is fine. Now we just need to implement this. I mean, maybe you can override operators.
I have no idea.
You see, if you scroll up to line 15, we already have add, so now we can just add subtract. For all the shade we're throwing it at JavaScript, you should also know that we're complete.
Totally.
Noobs at JavaScript.
This is only half JavaScript's fault.
Yes.
Maybe slightly more than half, but yes.
Okay.
I'm sorry, I couldn't have it be that long. It hurt me. I'm sorry, you were saying?
I think we should do a handle event.
I would love to see this work, but yeah, let's do a handle event. A handle event on our render size box.
So let's just put handle event on render box. We just have it everywhere.
Make it a layer.
Event, return false. Basically, a handle event function will return a Boolean that says whether or not it actually
Oh, okay, because
absorb the
that's
event.
how we had it here. Handle event, new click event. I see. So this is then. I'm confused. What is handle event now trying to do?
So I was going to write on line 230. We're going to have this dot set size. For size, this dot size.
Like, yeah. We somehow want the user to be able to define this code, but that's fine. We'll get to that.
Correct. But I think this is just to see whether our hit testing logic is doing anything. And then if we did this correctly, then the one that we click on should get bigger.
Okay. No. Show me the problems. Well, this is going to be a real problem.
Should we load it in a real browser? Since
that'd be totally cheating.
Yeah, I think if we can't see the console output, we're really going to have trouble.
Open in default browser.
You want to bring up the web inspector? Oh, Giphy. Hello, Giphy.
1 second. Let me make some of these go away. Okay. Back to the stream. All right. Let's inspect. Hit has already been defined.
Oh, I guess it's not legit to reassign. I've been writing too much Rust, where you constantly redefine your variables because you aren't allowed to mutate them.
Yeah, it is a little weird that Rust lets you do that.
It comes from ML, where you're constantly making new bindings for everything. Oh, we still have the alert. We should take out the alert.
Hit test is not a function.
We got to change it to. Remember, we were originally going to hit test on the window, but now we change it to hit test on the root.
Yeah. And where's our alert? I don't know.
You may just have to save your file.
Where is our render root? Tree.
Oh, tree. Yeah, there you go.
Click event is not defined. Not surprised. Are you doing it or am I?
Go for it.
Class, click event.
So I'm sort of amazed because we didn't apply the device pixel ratio.
Oh, is this maybe mine is just a device pixel ratio of 1?
It must be because JavaScript is giving us the coordinate in. Oh, look, that's a bug. Handle event of undefined.
That's just our main code.
Yeah, I think JavaScript is giving us the event in logical pixels rather than device pixels.
There you go. That works.
That's cool. Isn't that cool?
Yeah.
Like now it's feeling more interactive, right? Because you can interact with it and choose what you're interacting with.
Mm-hmm.
To me, that's always the fun of doing these like UI toolkit vendor object sort of thing is like you can interact with it and it responds to your input. You get the whole cycle.
Yeah, I don't know that we can do it in this episode because I don't actually know anything about how you'd set up JavaScript unit testing. But I really feel like without JavaScript unit testing and coverage, I just feel I feel scared to touch anything.
Mm-hmm. When I look to do it, basically it involves like installing npm, and then there are tons of great unit testing frameworks that are built on top of NPM.
Yeah, I have NPM installed, but okay. What other things should we do? We could add a rect class.
I think we should try to manifest this bug in layout where the layout is not getting recomputed.
What do you mean? Oh, I see. Where your constraints change, but your child doesn't need layout.
Correct.
Okay.
So the way that can happen in this example is if the yellow box touches the bottom of the screen.
Because the green box changed?
Correct. So right now, the yellow box is sticking off the bottom of the screen, even though it should be constrained to fit on the screen. I'm not sure how, like we probably need some way of, oh, you know what we can do? When we size the world here, we'll just size it to half.
On the screen.
Yeah. Let's just take the height and divide it by 2. And then does the window determine how big it is? That's not quite right. Let's leave the canvas to be the full size. And then when we size the root, let's give the height divided by 2 here. By that.
Makes sense.
Yeah. So you see that that's going off all the way to the bottom, but it shouldn't. Should.
I think we need to draw a outline for the root.
Okay, that's a good idea.
So we can see it.
This is also a very common debugging technique for render trees, is to draw outlines around things because you want to figure out like where the heck they are. We can just have the render root do that.
Exactly. What's this draw frame thing?
Draw frame is what's called in the framework.
That kind of frame. Yeah. I was thinking about like a frame around it. So here's your paint. Or have you already done it?
This has a paint, but it doesn't draw anything. It just draws that's the job draw.
Okay. This is some sort of like, this is something you would like put behind a debugging flag or something. Color the colors here.
I think they have like SK red or something. They have some very basic colors defined as constants. I bet they have red defined.
They do, you said?
Yeah. Like red. They don't have very many of them. We need to define the rect.
Not defined. We have to make this rect. Blah. Offset. Doesn't seem right. DX. We call off. Okay. That could be right. I would expect to see red. And I don't. Do I need to add a stroke here?
It should be able to fill the red.
Oh, it draw rect. I'm trying to think. It's like set style or something, right? I don't remember my Skia.
It's not going to know. Like you just have to guess what it is. But there isn't a ton of good documentation for this canvas kit library.
Yeah, stroke rect. SK Paint. Review. Set style. Okay. Where the frick is the stroke width? Canvas kit.
I was not able to find any good documentation for it, but this is fine. We can do a solid fill. I'm going to comment out the painting of the child and just see if we can get this rectangle.
There we go. They literally have this.
Oh, that looks good. Yeah, so our canvas kit is called SK.
Draw. Okay, surface strip once. Okay. And show me the money. Where'd it go?
We could try to I think we should try a fill first. Try it now. If we're painting an outline, it may be outside what we can see.
Weird that it takes so long. What if we comment this out?
Okay.
Oh, I see. You commented out the child. That was our.
Yep.
What this thing is. Ink. Set color. Stroke. Any alias.
I was making an R rect, but same idea. Wait, we can just do a fixed size rect here. Let's just do like a 10. I wonder if our rectangle is not quite right. Whoa, those are some crazy demos.
Left, right, left top, right bottom.
This should be like a little 90 by 90 rectangle.
Okay.
Yeah, so there's something about our width and height we're wrong.
Do we not lay out the
We should. Let's try this. So now I'm sort of interpolating back between.
We do set our child. Do we set our own? I see. When we set our child offset, do we set our own offset? Doesn't look like we do.
Our offset will default to 0. I suspect somebody's size is not getting set. Like maybe the render top and bottom. Oh no, this dot size. Well, we'll keep debugging it.
Okay.
So if you go to line 209, I'm sort of interpolating between the thing that drew a red square and a thing that didn't.
Okay.
The offset looks fine. So we should console.log the width.
I don't see any console.log. That's very strange.
Okay.
Get it? No, nan.
Oh, NAND. Okay.
Guys are with nan.
So let's try console.logging the size.
I think I don't have save on. Oh, there we go. And nan.
So can I console.log this? We might be able to explore the render tree from there.
Let's save on. Okay, render root.
Okay. So its size is NAND. That's great. Its child. Its size is NAND. Okay.
Top. Its size is
has a legit size. It looks like top and bottom is not computing its size in a reasonable way.
Those look reasonable, but the top and bottom itself is presumably just never setting its own size.
Well, it says it here, but maybe it's messing up in some way.
Math.max.
Oh, look at that. That size, that height, versus top dot bottom dot size, that height. Like this is like we're collapsing in our own weight here. That. What's amazing is that everything is like has run. Like that's the amazing thing to me about JavaScript and browsers, is the thing is just like completely full of bugs and total nonsense, but it like runs and kind of works. It's like, how is this even possible?
I love you, JavaScript. Okay. We have a size.
We have a size. Oh, the humanity.
Okay, so I think we can finish our interpolation here.
So let's go back to our old rect. And see if that works.
Whoa.
Okay.
That looks right. Yeah. All right, so now let's stroke. That looks right too.
All right, so let's turn the Java on. Is that like stroke width?
So the render root is just getting bigger. Is that what we expect?
Or it should stop at some point. Try to set our stroke width to 5.0, see if that actually does something. Oh yeah, big honking line.
So when should it stop?
When we get to half, right? Because we set the I thought we set the height, the max height to half.
Let's see.
Oh, you know what? Maybe we didn't account for the device pixel ratio.
We really want to like get into device pixel ratio and just never leave. Like we don't.
Yeah.
What is this? Why does it not have any?
That's the prototype object. I would expect it to have a min width, min height.
Something's funky. Let's go back to our doing layout here.
Can we debug it in the inspector? Does it have a debugger?
Here?
I'm just wondering if the web inspector has a debugger that we could use.
Probably.
You could go to
Anyone watching this who does actual web development.
It's just like, what are these?
Yeah. Who are these idiots? And they worked on web browsers? What?
I think if you scroll down, if you shrink the size of your console to be less than enormous, in the sources panel, if you go to lib.js, I think you can set breakpoints.
Hold on. If I go to lib.js.
No, in Chrome.
Oh, in this thing.
Yeah. Yeah.
Okay, what am I breaking point on here?
Let's do layout. Yeah, right there. Yeah. Now try reloading the page. Oh, there you are.
Okay.
So you have your variables over there on the right. It's terrifying. I completely agree. But somehow, like many trillions of dollars of commerce, is supported by this thing. It's
I don't know.
Amazing success story.
I don't know if he was or she was commenting on browsers or those of us who worked on them, or both.
It turns out you don't really need to know anything to do things. You just have to know how to find your way through the problem. Why the constraints has no properties on it, I have no idea.
Well, let's see who's passing this thing constraints. Someone's just passing
But it works.
Prototype.
If you go in the console, can you type are you in the scope of the debugger? Can you type constraints.minwidth? No.
Box constraints.
Oh, look at that. Wait. That was it. You saw the bug.
And that we passed in a constraint instead
No,
of
no,
a block?
look. It was on the screen. Go back to it. The constructor for box constraints very handily reads all of these fields
and doesn't assign them.
Never assigns them. But somehow everything has worked up to this point.
Oh my god! Can we go back to Rust now?
How is this possible? That like our main like data structure that we're passing around, doing all this very complicated, elaborate math with, actually we never actually assigned any of the fields. I said it was full of bugs. I did not realize the depth. I thought they were like subtle bugs. Like, oh, let's illustrate this subtle bug about this render tree invalidation that we're not quite computing correctly. So no. How about this like major bug where your data structure never assigns its values? This may be the last JavaScript project we do for a while.
Does this thing, is it fancy? Can I do this?
No, I don't think so. Look, that's another thing that really coming from Dart. Like, there's so many things that in Dart are very like terse that I don't believe there are any terse ways of doing. Like, you have to manually call super for like a 0 argument super. And most languages will do that for you implicitly if there are no arguments.
Superclass that does this. What? Oh my god.
Yes, it's amazing.
Oh wow.
I was thinking it was really basic. Like I didn't use getters or setters or anything because I just wanted to like keep it vanilla.
One of the things I was thinking about today was that I was going to get to see all sorts of modern JavaScript. Because I hear it's changed a lot in 6 years since I last.
Maybe we should have a guest who like actually knows modern JavaScript and show us like.
We totally should. They can blow our mind.
Oh, I'm glad this is entertaining. I'm finding it wildly entertaining as well.
Okay. How do I even?
So I made the assignments.
Oh, good.
The fields of the variable.
Good, so and we think that they're correct. We put the min and the min and the max. Oh, good.
I used the copy paste.
The copy paste of Destiny. Okay, what?
You still got your breakpoint. You probably take your breakpoint off.
Oh, look at that!
Oh,
cool. That's high quality.
The developer tools are very nice. I really.
What did you say?
These developer tools are very.
Oh
nice.
Yeah, I mean the Chrome developer tools are amazing. Okay. Oh.
You hit the limit. But now we've manifested the very.
We have manifested the bug
that we were hoping to manifest.
We had to get through to get here.
We have snorkeled through the mud. We bumped into the wall that we knew was there.
Okay. Shall we fix the bug?
Let's try to fix the bug. So I think we need an equals function on box constraint, which I can write here.
Oh my goodness. I want Rust macros.
In the previous episode, I constantly forgot the word "this" in front of everything, and so it was just a disaster.
Oh, I see. There's your equals.
Yep.
I want Rust traits.
Yes. Or even just operator overloading would be nice. Or really just like telling me that I didn't assign the variables. That also helped.
I'm going to give a D to your width here. In case.
Yes.
This JavaScript wasn't going to tell you. Okay.
Does that look halfway plausible?
That looks reasonable.
Okay, so now we get to do perform layout fancier. So we want to say this dot constraints null After we
Where we
succeeded
go?
in layout, we want to remember our constraints.
Mm-hmm. Yep.
This is like previous constraints.
Mm-hmm. Yep.
Here's our constraints. Okay, so if this doesn't need layout, and this dot constraints thing equals null, and this dot constraints equals constraints, then we can bail out.
Why don't we just say that? Oh, I see. Because this constraints could be null.
Right, because we initialize this to null in the constructor.
Can constraints also be null? The one that's passed in?
I guess we can initialize it to box constraints 0, 0, 0. A reasonable box constraints.
And then we can just remove that. Okay.
There's non-nullability that would have let us remove the nullability annotation. I think this will fix the bug.
Should we run a test? Oh, look at that.
Look at that.
Interesting that it lets...
Well, it'll stop. Keep going the green thing. Eventually the green thing will smush the yellow thing out of existence. Smushed out of existence.
Well, there we go. We did it. We fixed our bug.
We fixed our bug. No, we did it. We did hit testing. We did some very basic event propagation. I had a whole plan. I wanted to wax poetic about like bubbling up versus bubbling down of events, but we didn't quite get there. I'll give that speech. So our hit testing that we just did here is very basic, right? You hit test, you get back a single thing that you hit. Typical render tree is a little bit more sophisticated. It'll give you back the path. So like a chain from the root down to the thing you hit. And then different UI toolkits have different philosophies about what do you do with this path when you're dispatching an event. So one thing you could do is you could start at the root and give the event to each of the nodes in the tree until you hit where you're going. The other is the reverse. You start there, you check, and then if it's handled, you stop. If it's not handled, you continue. The web, of course, does both because the web is amazing. There's the capture phase and the bubble phase, which are those two different phases. In Flutter, what we did is we hit tested down and then bubbled up. And then for use cases that really wanted the capture phase, they sort of like hook in the hit testing phase and sort of cheat their way in that way. But anyway.
Yeah.
Cool story, bro. Then I found $5. I don't know. How do you end stories like this?
Speaking of stories, do you have any stories to share this week before we part ways?
Oh, that's a really good question.
You were telling me you wrote the hardest patch you had in months or something.
Oh man, okay. So I was implementing rename for a POSIX file system, and rename is super duper complicated. The trickiest part of rename is so you go and find the two parents, like the old parent and the new parent. Then you have the child of the old parent that's going to become renamed to be the new parent, and then there's a fourth node involved, which is if the new parent already had a child with the new name. That's not always an error in POSIX. In POSIX, it's allowed. If it's a regular file, the new one just clobbers the existing child. If it's a directory, it can clobber it, but only if the directory you're clobbering is exactly empty. And then in order to do this in a multi-threaded system, you have to hold locks on all of these things. So they can't so the directory that you're replacing can't become populated in the middle of your rename operation. Mm-hmm. But then you have to take these locks in an order that will guarantee that you don't deadlock. Because if there are two rename operations in flight and you don't have a systematic way of acquiring the locks, they could interlock and deadlock. And man, it was really, it took me like 2 days to write this patch. And I thought, oh, rename, that's not that hard. I'll pull it off the ticket queue and I'll just hammer it out. I was like, oh, wow. Anyway, I think I have it without a deadlock. Like we pass all the tests and we can run a bunch of software with it, but I would not be surprised to find out that there's a deadlock in it somewhere still.
Great. Well, I was mostly on vacation, so mostly reading fiction novels, which was amazing. But I did do a little bit of Rust programming. And I learned that getters in Rust are maybe broken is too strong a word, but it's a bit of a foot gun, because if you write a getter like you would in any other language, when at least the naive way that I know how to do it with Rust is you end up turning your you end up taking mutability, or you take a reference on the entire object, right? Say you return a reference. Say you want to write a getter that would access some property foo on your many variable object. Normally, Rust is smart, and you can do a partial borrow of the struct, right? So say you have a struct that has foo, bar, and baz. You can both borrow bar and baz independently, separately, and do things with them. But if you instead write a getter for bar, are you following me?
Yeah.
If you write a getter,
I had no idea getters existed. I only know how to write functions.
Oh, well, I mean, it isn't a getter. It's just a method. But say you wrote a method named bar that wanted to, like, because you wanted to make it private or whatever. Rust has no way, the compiler borrow checker has no way to know that your getter isn't like doing things all over the object. And so that self-reference that it took as the first parameter to your just random method getter. And I was chit-chatting with a friend of mine who's on the Rust core team, and he mentioned there's some way to get around this, and I sort of found something on Stack Overflow, but I haven't internalized how. But the naive way of writing a getter is dangerous. It's dangerous in the sense that you suddenly you can write exactly one getter for your object because you borrow the whole darn thing.
This, like, to me, Rust and JavaScript occupy totally opposite sides of the spectrum. In JavaScript, it's like, YOLO, don't bother assigning your fields. Your program will just run fine. Don't worry about it. And Rust is like, but when I calculate this and I correlate it with this other part of your program, I detect that maybe you might have a bug in some esoteric situation. Please prove to me that you don't have one.
Yes.
And you're like,
please submit your TPS reports in triplicate.
Yes.
Yes. I was thinking actually today about like how would we write this in Rust, and I actually was wondering. I think we would just be fighting different issues, because we'll end up with like a borrow a tree of ref cells or whatever.
Yeah, I think it'd be tricky because, like, first of all, you don't have inheritance to work with, and then you're dealing with trees, which are tricky in Rust.
Yeah. The real answer is we should just all write it in Dart.
In fact, it works really well in Dart.
Anyways,
database like transactions for file systems. Yeah, that actually would be really cool.
Anyways, Dr. Barth, it has been a pleasure as always. I'm going to go get some sleep, and I will see you next week when it will not feel like 3 o'clock in the morning, my time.
Sounds great. See you next week.
Take care.